I searched the internet to try to find a good Wankel Rotary engine example, grabbed CAD and other sites, and all of the examples that I found weren't technically correct. So I ended up having to model my own engine block, and I'm going to show you how to do that. Now if I play the animation, we see how this rotor walks its way around this pinion gear here. So let's play that again. And it takes 3 revolutions of the crankshaft to go for the rotor to go around 1 revolution. And then these seals are pressed out against the block to maintain a compression seal between the 3 chambers. And so I have over here, I have a revolution joint for the crankshaft, a revolution joint between the rotor and the crankshaft, prismatic joints for each one of the seals to push them out against the wall of the block, a rolling cylinder in cylinder for the ring gear and the pinion gear, sliding joints for the seals, and then spring joints to hold the seals out against the block. And so let's look at how all of this is done. So let's play it one more time, and I'll slow it down a little bit here. So well, let's just go ahead and play it. So let's look at how this is all done. I created a new project file, and then I created a metric assembly file and saved that as Wankel Rotary Engine. I'm now going to place the block, and so I'll select the block and I'm going to place it at the origin. So I'll right click, I'll say place grounded at origin, and I'll hit escape. So the origin is in the center of this block, and the outside of the block could be any shape. I've just used an image off of the internet to model something that looks appropriate in size and shape. So now I want to create the gears. So let's go ahead and save this, and then we'll go to the design tab, and I'm going to select Spur Gear, and I want to create an internal gear. So make sure that I have that checked as an internal gear. I'm going to do a pressure angle of 20 degrees with a 5-degree helix angle. The number of teeth on my Spur Gear are 34 teeth. The number of teeth on my ring gear is 51 teeth. I'll do a module of 1.75 and a face width of 20. I'll go ahead and say OK to create my gears. It shows the display name. I'm going to rename the first gear as 34T Spur Gear, and I'm going to rename the second one as 51T ring gear, and I'll say OK to that, and I will then click somewhere on the screen to place those 2 gears. I want to do some editing of each of these gears, and so let's look at the drawings we'll look at the Spur Gear first. I should have referred to this as the Pinion Gear. They're both spur gears, and so I'm going to drill 6 holes in the face of the gear. I'm going to break the sharp edges on the hole with chamfers, and I need to export the pitch diameter variable DA underscore DW. I'm going to shift right click and set my my selection filter as part priority, and then I'm going to open the pinion gear. I'll start a new sketch on this face, and then I'm going to draw a circle at the origin, and I'm going to make that circle a diameter of 40, and then I'm going to draw a second circle at the origin, and I'm going to put a point at the 12 o'clock position on that circle, and I need to make sure I put a vertical constraint between this point and the origin. I will dimension this second circle a diameter of 47.5, and I'm going to change this second circle to a construction circle. Alright, then I want to cut a hole through the part with this circle, so I will do extrude, and I'm going to select cut through all, make sure the direction is going in the right direction, say OK to that. I'll make that sketch visible again, and then I will do hole. I'm going to select a threaded hole, a tapped hole, M5, 0.8 is the pitch. I'll set a countersink 6 millimeters, drill depth or a tap depth of 10 millimeters, a drill depth, we'll just leave that at the default. I'll say OK. Now I have a threaded hole going into the part. I'm going to do a circular pattern of this feature about the axis, 6 copies. I'll say OK to that. I'll turn off the visibility of my sketch, and I'm going to put a chamfer on these edges here and here to break those sharp edges. Let's say 0.5 millimeter for that chamfer. I want to put a chrome texture on this. Go to my appearances and I'll select chrome. Alright, I want to do a couple more steps. Turn on the visibility of this pitch diameter. So I have a cylindrical surface body here that represents the ideal contact point, or the pitch diameter. And let's look at the sketch for that pitch diameter. So I'm going to edit that sketch, and I want to see this variable name. I'm going to double click on that, and we see that the name of that variable is DA_DW. I want to mark that variable for export. So let's go to the parameters, and I'll find that DA_DW. That's the pitch diameter, and I'm going to mark that as a key dimension, and I'll mark that for export, and I'm going to call that then 34T Pinion pitch diameter, and we'll see why we did that in a little while. I'm done with this part, so I'll save it. I'll go back to my assembly. Next I want to create the rotor, and I'm going to start with this reference circle diameter 210. So let's look at how that is done. With my selection filter set on part priority, I'll open up the ring gear. I'll start a new sketch on the XY plane, and I'm going to draw a circle, and we'll dimension that as the 210. And then I'm going to draw a triangle. So I'll go to polygon, I'll do a triangle, 3 sides, and I'm going to draw this triangle up to the 12 o'clock position. And we need to add a horizontal constraint on this triangle to make that fully constrained. I'll then change all of this to construction geometry, and I'm going to move this dimension down here. And then I'm going to draw an arc, and I'll draw the arc from here over to here. Make sure it's snapping green to those points, and I'm going to make that a radius of 215. Let me drag the dimension down here, and then I'm going to do 2 more arcs. So I'll do an arc from here up to here, make sure it snaps green, and from here up to the 12 o'clock position, make sure that it snaps green. I'll then control select each of these 3 arcs, and I will make those equal. It all turns black. It's all fully constrained. I'm going to project geometry the edge of this gear, so I'll do project geometry, select the edge of that gear, and then I'm also going to draw a circle here at the origin. We'll do that as a diameter of 70. I'll then finish sketch, and I want to put a work point at this location that we will use later. So I'm going to do point. I'll select that point, and then I'm going to start a new sketch on the XY plane, and I'm going to draw a rectangle, and initially I'll put it out here in space. The dimensions of this rectangle, this distance will be 15 and this distance will be 4. I'm going to put a coincident constraint between the midpoint of this line and this point. I'll finish sketch and save it. Alright, now I'm going to do extrude, and I'll select this area, and I'm going to extrude that to this face, but I want this to be, the rotor to be a separate part from the gear, and so I will select new solid. I'll say OK, and so now I see that I have 2 solid bodies, and then I will make the previous sketch visible again, and I did edit sketch. I want to just make that visible, so I'll right click, turn on the visibility, and then I'll do extrude again, and this time I'm going to select both the triangular area and this area. I want to do join, and I'm going to go a distance of 60, and I need to make sure that it is joining it to the rotor portion and not to the gear. So I'm going to click solid, and I'll control unselect the gear, and I'll select the rotor so that it's joined to the rotor and not to the gear. I can check that now by turning off the visibility of the ring gear, and I'll turn off the visibility of that sketch, and then we will cut our slots through for the seals. So I'll do extrude, I'm going to do cut, and I'll select through all, mid-plane, make sure it's previewing OK, and then I'm going to do a circular pattern of that last feature. I'll do that about the center of the part, 3 copies, say OK to that. And then I'm going to select one of the edges of this slot, and I will do a fillet, and I'm going to do 0.5 fillet on the edges, the outside edges of the slot. and I want to break these sharp edges, so I'll do a chamfer, and I'll do a 0.5 chamfer on that edge, this edge, and this edge. I'll save it, and let's go ahead and name this second body as Rotor. I'm going to turn off the visibility of the second body, turn on the visibility of the ring gear, and I want to put some chamfers on this edge as well. So I'll do chamfer, I'll select that edge and that edge to break those sharp edges. I'll turn the visibility of my rotor back on. I'll go back to my assembly, and then I want to place this onto my block. And so I'm going to do constraint, and I'm going to select flush. I'm going to select the face, the front face of this gear to the face of the block. I'll say apply to that, and then I'll put it back on mate, and I'm going to get the Z-axis of the block or housing and the Z-axis of the 34 tooth pinion gear, and that moves that over into place. Save this. Alright, now for the purposes of making things easier in dynamic simulation, I'm going to promote those two parts to the assembly level. So I'm going to hold down the control key, and I'm going to select these two parts, and I'll right click, and I'm going to do component, promote the design accelerator components into the assembly. Then I'm going to right click on the spur gear and ground it. I'll delete the subassembly node, and next I want to create the crankshaft. When I look at the dimensions for the crankshaft, I realize that I didn't export the dimension for the ring gear pitch diameter, so we need to go back and do that first, and then we can continue drawing. We'll put the pitch diameter of the ring gear tangent to the pitch diameter of the pinion gear, and then we can draw the dimension, the circles, to extrude the crankshaft. So first thing we need to do is we need to go back to that ring gear and open it, and I'm going to turn on the visibility of the pitch diameter. Okay, so that's an extruded surface, a cylindrical surface, and then we also need to set that parameter. So we'll go find the DA underscore DW. I'm going to set that as a key parameter to export it, and let's call this pitch diameter of ring gear. We'll put in the 51 teeth, and then I will go back to assembly. I need to create a new part, so I'll do a new metric standard millimeter part. I'll start a new sketch on the XY plane, and I'm going to draw a circle. I'll draw that circle at the origin, and then I need to import the dimensions for the pitch diameter of the pinion gear and the ring gear. Let's go ahead and put in the ring gear. I'm going to draw a circle somewhere on this line, but not at the midpoint of it, somewhere on this line out to the end of that line, and then make those tangent. So this circle is tangent to that. I'll change all of this to construction, and I'll save it. So I'll finish sketch, and we'll name this crankshaft. So I need to get those dimensions, the exported dimensions, from the other two parts. So I'm going to go to the Manage tab, and I'm going to select Derive, and I'll drive the the two gears. And when I do, I don't actually want that solid body, and I don't want the surface body. What I need is the parameter, and I've already marked that parameter for export, so it's highlighted here, and so I'll say OK to that, and that brings the parameter into this file. And then I'm going to do the same thing with the other one, so I'll do Derive. I'll get the second gear. Again, I don't need the solid body, I don't need the surface, I don't need the work point, I just need the parameter DA underscore DW, that's the pitch diameter. Okay, now that I've imported those two dimensions, I can edit my sketch, and I want the sketch to occur after, in history, I want the sketch to occur after the imported dimensions. So I'll edit the sketch, and then I'll do dimension, and I'm going to select the smaller circle, and click on the black arrow here, and I'll tell it to list parameters, and we see the two parameters that we created. Notice that they were the same name, DA underscore DW, but Inventor automatically put an underscore 1 here to let us know that this was a second import. And so I'll dimension that circle, and I'll dimension this circle. So I'll do list parameters, DA underscore 1, and I might want to see those dimensions. So I'm going to come over here to tolerance, and I'm going to say expression. So we see that that was DA underscore and then DA underscore 1. So the two diameters of the pitch diameters. I'm then going to draw a circle at the origin, and I'm going to make this diameter 40, and I'm going to put a second circle somewhere on this line, but not at the midpoint of that line. I'm going to draw it from here up to this point, and I'm going to make this circle then concentric to this circle. So I'll do concentric. This circle is concentric to this circle, and it's also tangent to this circle. I want to allow a little bit of clearance for the crankshaft going into the holes. So I'm going to change this diameter a little bit, make it a little bit smaller. Let's make it 39.9. So that'll give me a little bit of clearance, and because this is tangent, this also got slightly smaller. Alright, now I will do extrude. So I'll do extrude, and I'm going to dimension or extrude this smaller circle a distance of 20 millimeters. I will then turn the visibility of my sketch back on, and I will extrude the smaller circle and the larger circle. I'm going to do join, and I want to go a distance of 60, and I want to bring the first extrusion out a distance. Let's just edit that first extrusion. So I'm going to say edit feature, and I'm going to put it on asymmetric. So I'll go 20 in the first distance. Now on my drawing I went 80 for the second distance. I'm going to go a little bit further. Let's go 100 for the second distance. I made that a little bit longer to transition to the next lobe. I'll turn off the visibility of my sketch, and I want to put a fillet on this edge and a fillet on this edge. So I'll select that edge, I'll do fillet, and I'll select these two edges, and I'm going to do that as 0.5, and then I'm going to put a chamfer here and a chamfer back here. So I'll do a chamfer, and I'm going to do that as 1 millimeter. I will assign a material to this. I'm going to make this crankshaft stainless steel. I'll save it. Then I'll go back to my assembly, and I'm going to do place of the crankshaft, and I'll select some place on the screen. I'm going to insert that crankshaft into this gear, and it might be easier if I turn off the visibility of the housing block. And so then I can do constrain, I'll do insert, I'll select, make sure you get the outermost circle and then the outermost circle on the pinion gear. I want that the other way around, so I'll flip the alignment and I'll say OK to that. Now if we drag rotor, we see that it can still move. I want to constrain, and I'll do the insert again. So I'll do constrain, I'll do insert. This time I'm going to select this circle and this circle. And again, I want to flip that direction. I'll say OK. I will save it. And then I want to put a home position constraint to line this up. And so let's do a constraint, and I'm going to select on the ring gear. I will select the YZ plane of the ring gear to the YZ plane of the assembly, and I want that to be either mate or flush. If it flipped it around the other way, see, that's not the way I want it. I want it like this, and so I'll say OK to that, and let's go ahead and rename that constraint. And so I'm going to call that home position, and I'll put a reminder in here, so I'll say dash suppress this. So in order for the gear to have a degree of freedom where it can move, we will have to suppress this constraint, but anytime we want to get back to this position, we can unsuppress the home position constraint. So if I try to drag anything right now, everything is fully defined, nothing can move. I'll save it. Before I go into dynamic simulation, I want to check out the kinematic motion in the assembly environment, so I need to add one more constraint. I need to add a motion constraint, and I'll put it between the circle on the end of this pitch diameter and the circle on the end of this pitch diameter, and it determines the ratio between those two pitch diameters. I like to have my home position constraint at the end, so I'm going to drag that down to the end, and I'll need to suppress. I need to suppress that constraint so that I can test it out. And I test it out, and I see that this gear walks around the pinion gear. Now I want to put this back to the home position, so I'll right click, unsuppress. That puts it back to the home position, and then I need to suppress it before going into dynamic simulation. So I'll suppress that constraint. Right now we have the housing body is invisible. We'll turn that on in a few minutes. So So I'm going to go to Environments Dynamic Simulation, and we see that we have two revolution joints here, but the motion constraint did not get converted to a dynamic simulation joint. So we need to insert that joint. So I'll do insert joint, rolling cylinder in cylinder, and then it's important we pay attention to which components we select first and second. Also, we already have those two cylinders tangent, so we only need one solution. We don't need two constraints. So I'll do one constraint, rolling. It says select the outer component first, so we'll select this circle first, and then I'll do the second component. We'll select this circle, and we'll say OK to that. Alright, to drive this, I need to find the revolution joint between the crankshaft and the spur gear. And so I'll right click, I'll do the properties, and I will enable impose motion, and let's do a constant value, let's say 600 RPM. And when I hit the tab key, it'll convert that to 3600 degrees per second. I'll end up wanting to revolve this 3 times, so we'll set the amount of time to run this as we see it revolving. Let's increase the number of calculations. Okay, so we see that the rotor walks its way around the pinion gear and the crankshaft rotates. Now, in order to do one complete revolution of the rotor, we need to do 3 revolutions of the crankshaft. If we go back and we take a look at the properties, so we're doing 3600 revolutions of the crankshaft, or degrees per second. So to do 1 revolution would be 1/10 of that, and then we need to do 3 revolutions, so 0.3 times 1/10 of a second. So we'll say we'll put in 3/10 of a second, and we'll run this then, and let's say we'll do 720 calculations. So counting, so this point, it should go around 1 time in 3/10 of a second at 600 RPMs. And we're back to where we started. All right, if we turn on the visibility, I'll go to the grounded groups. I'm going to turn on the visibility of the housing, and so if we play this again, we see the rotor making 1 revolution. And I really like to put a timing mark on the crankshaft so that we can see it moving as well. So let's go back and do that. So I'm going to exit out of dynamic simulation. I'm going to open up the crankshaft, and I'm going to do a new sketch on the front of the crankshaft, and I'll project geometry, this outer circle, and then I'm going to draw a rectangle, and I'll put it out here in space initially, and then let's do vertical constraints. So I'll do vertical between the midpoint of this line and the origin, and then I'll make this tangent between here and this circle. I will put some dimensions on here, so let's make this height 7.5, and I'll make this width 2 millimeters, and then I'll do an extrude cut, put it on cut, and I'm going to go a distance of 0.1 millimeter. Let's go a little bit deeper than that, let's say 0.5. Change the color of that extrusion, so I'll go to the properties of that extrusion and change that to some other color, and so that will serve as a timing mark that I can see as the crankshaft is rotating. I'll go back to my assembly, and we can't see it yet because it's buried inside of the block. We can see the outlines of it, but we can't see the color. So let's play this one more time, and so I'll go to dynamic simulation, and we'll play it, and so we see the crankshaft going around, and it'll go around 3 times for the rotor to go around 1 complete revolution. So I want to cut a cavity in the block for the rotor, and so to do that I'm going to place a trace, and I may need to go to a wireframe view in order to see this. So I'll go to wireframe view, and I'll place a trace, and I want to select this point that we made earlier, and so I'll put my mouse here and select other, and I'll get that work point. I'll run my simulation, and we see that it's tracing out the path of one of the points on the rotor. And then when it completes that path, I want to export that path as a sketch to cut a hole in the block. And so I will go to the output grapher, and I will drill down and I'll find that trace, and I'll right click and I'll say export to sketch. And it isn't real obvious, but down here in the lower left hand corner it says select a component where you want to create that trace sketch. So I'll select the housing, I'll finish dynamic simulation, and I'll open up the housing. And so we see that we have the sketch is now projected into this part. And so I'll do then an extrude cut both directions through all to cut a cavity into our block. Now I already have another extrusion for the spark plug holes and for the exhaust port. I'll save my assembly. And so we use the motion of the mechanism to define this cavity. We'll go back and I'll update my assembly. Need to make everything shaded, so I'll do shaded with edges. So there is our mechanism. I could turn off the visibility of the surface bodies, so I'll go to the View tab. Under Object Visibility, I'll turn off the user work points, and I'll turn off construction surfaces. Save it again. We'll go to Dynamic Simulation, turn off that visibility or delete the trace, so we don't need to see it anymore. I'm going to go down and I'll delete that trace. Then we can rewind it and we can play it again. So the crankshaft rotates 3 times, and the rotor will do 1 complete revolution. And the challenge then is to add the 3 seals with the spring force holding those seals out against the block.